so the three equations of motion and F is equal to ma, four derivations that we've derived time and time again, but let's have them all available to us here now in one very quick clip. Okay. So what you need to be able to do in each case is know where to start and know what to do in between. Okay, so let's rattle through them quickly. The first one, V is u plus at. Okay, where do you start? You start with the definition of acceleration, but you write it mathematically. Acceleration is a change of velocity over time. So A is v minus u, change of velocity over t. Okay, then you just rearrange. So it's at is equal to v minus u, so v is equal to u plus at. Done. Okay, so what you do, start with the definition of acceleration, rearrange. Effectively, it's just a rearrangement of the definition of acceleration. Okay, second one, you start with the fourth equation that's in your maths tables, which is that the distance travelled is the average velocity times time. So you start with that, it's given to you. Okay, you then look at it. So that's how you remember how to start. Then you look at it and you say, okay, the only problem I have here is, sorry, I didn't write down the actual formula there, which you always have. Okay. So I need to get rid of the v. The v is my issue. So I use the first equation. So instead of v, I'm putting in u plus at. Okay. And you don't need to multiply that out as though you're doing a maths question. God help us. Okay. You just write down your answer because it's obvious. Okay. There's no physics in that step. Just a bit of simple maths. So you just write down the answer. You're done. Okay. So let's recap. Start with the fourth equation, distance, average velocity times time. You have a v, get rid of the v using v is u plus at, sorted. Okay, third one, you want to get v squared is u squared plus 2as. Hopefully it's pretty obvious. You start with the first one and you square both sides. So start with the first one, square both sides. Okay, be careful with the square, remember it's the first one squared, second one squared plus twice their product to UAT. Or if you need to multiply them out, just write in the two brackets and multiply them out, whichever you prefer. Okay, I'm using the shortcut that you would have from your algebra. Okay, and then the next step is, and this is the one that catches people, you want 2a, so you have your v squared and your u squared. We want 2a here, so we take out the 2a, we take out the 2a, factorize, it looks a bit odd, but so you have to put in a half at squared. That should be a squared t squared, half a t squared plus ut. Okay, that was my mistake there. U squared plus a squared t squared. Okay, and what's in the bracket is the second equation, so that becomes s. Now we're sorted. Okay, and you can, as I did there, you'll find the little errors as you go along. No problem. Okay. Fourth one then is F is equal to ma. Now F is equal to ma is slightly different because they'll say use Newton's law, second law, to show that F is equal to ma. So that kind of tells you where to start. You start with Newton's second law, writing it mathematically. Okay, so let's have a look. Force is proportional to the rate of change in momentum. So it's the change in momentum, delta mv over delta t, because it's the rate of change. Remember, if it just says rate of change, as you know from your differentiation of maths, that means divided by time. Rate of change with respect to time is the default. Okay, and that's what we always have in physics, right? Okay, the change in momentum will be caused by a change in velocity, not a change in mass. So you take out the mass, and you're left with that. We know that delta v delta t is equal to a, so we write as F is proportional to ma. If it's proportional, it's equal to a constant times ma. And then the definition of the Newton is that a force of 1 Newton, if there's a mass of 1 kilogram, gives an acceleration of 1 meter per second squared. That's a definition you know, obviously, because you know all your definitions. Okay, right? So that only applies if k is equal to 1. So you say from the definition of the Newton, k is equal to 1. So you end up with F is equal to ma. And you're done. That's it. That's the 4. Make sure you know them. You have them here to recheck. The only way to learn them is to just take out a piece of paper and rattle through them every now and again. Okay, very good. Bye bye.